I'm Matthew Dromfield from Freyssinet, UK, and I want to tell you about the eBridges bearing replacement. The bridge consisted of 30 supports, 2 abutments, 28 piers, 2 half joints and then 4 moving expansion joints. The covers corroded, as did the bearing surfaces, and the bearings locked because the stainless steel deflected. To replace the bearings was very complex, and it required, firstly, careful handling of the live structure, and secondly, exact fitting of the bearings in a limited space. We don't have to travel far for challenges in space, and maybe we should tell Elon Musk about that as well, with all his rockets that are going up there now. The existing bearings were made to the old standards, so it meant that the newer standards need more space. The temporary works needed was significant. Large amounts of access, special jacking frames, supports, and making sure that in a temporary situation we could allow the live load to keep traffic going on the motorway above. Specially designed sledges, as we call them, were tested to check the woodwork with the structure. We analysed the stiffness of the elastomeric bearings, and we modified and then we retested the bearings to achieve the goals set by the designers. They were carried out at the Freyssinet test labs in Milan, where we could leverage our experience from working with seismic and special bearings. We developed a temporary works arrangement that would release load carefully to reduce the risk to people and to the structure. The collaborative approach through our teams and with the client's teams made it a very successful project. And one major contributing factor was the ability to train and simulate working conditions at the pierhead. Mock-ups saved time, money, and it also contributed significantly to excellent safety record during the project. Good planning, measuring and efficient feedback to the factory was another essential factor. When we finished the project, we then fitted the bodyguard protection system to extend the life and keep away all the components of corrosion, dust, VOCs and water. Most importantly, the new bodyguards prevented lock-up problems in the future. So for the future, we leave behind us better bearings in a few key ways. We used the new material called Isoglide, which is a high performance material giving 5 times the life of PTFE. We left clever seals, and the seals that go around the PTFE keep the grease inside, so that when the bearing is moving, the grease is inside, lubricating long term. And then finally we added the bodyguard, the state-of-the-art protection system which allows you to easily unzip, unwrap and inspect, and it avoids the problem of lock-up. Thank you for watching this short case study, and as everybody says nowadays, please subscribe, you know. But rather than subscribe, if you want to get in touch and you want to talk about other projects that are interesting, then please get in touch with me. I'm Matthew Dromfield, and I'm with the team at freyssinet.co.uk.